many other companies that are actually involved in the VeriDevOps project, like Team, Obo, Montimaj, Ekerland, ABB, Pagor. So we thank everyone for joining us. So this session will be recorded, so just in case you should know about that. And we are going to distribute these recordings to promote material that we presented in this book. So I will give you a short agenda about this event. So we will start with some very short presentation about our project and our initiative for cybersecurity in DevOps. After that, we will go and present chapter by chapter all the contributions that we included in the book. And our book is structured in 3 parts. Following the DevOps cycle, so starting with security requirements engineering, and we'll present 3 papers there. My colleague Edward will present taxonomy of vulnerability, attacks in industrial PLCs. Then I present our paper on natural language processing and machine learning for requirements analysis, and present some practical approaches. And after that, also some lightweight methods for security requirements formalization with a tool that we call RQ code. After that, we'll have a short break, just to relax and switch a bit. And we will continue with the part on prevention against specific security vulnerabilities at development time. And our colleagues from Ekerland, with Jose Luis or other speakers, we'll talk about vulnerability detection, response, about the current states and new approaches. Then colleagues from Obo Academy, Gadha, will present metamorphic testing approaches and fault localizations in industrial control systems. Ramon Bacara from Fraunhofer Focus Institute will talk about interactive approaches for security testing, this hybrid fuzzing. And we'll end this part also with a short break, so to relax a bit. After that, we will talk about operations and what we can do about cybersecurity in our operations. And our colleagues Laurent Sion from University of Leuven will talk about STAM tool on continuous threat analysis and management. Tanvir Ahmad from Obo Academy will talk about early, the tool that use machine learning for quick and early detection of security attacks. Then Sylvain Haré from University of Montreal will discuss about team-based approach for drone detections, and Mang Dang from Montimaj will talk about explainable AI for anomaly detections. And then we'll wrap up the session with make a small discussion, small summary of the day. So it will be quite intense, you see. So we'll talk about 5 hours in total. So yeah, these sessions will be recorded and our colleagues from Milton University will publish that on the internet. So we'll have these materials after for the analysis. Also, it should be noted that the book is coming, and from the latest news that we got from our publisher, currently the publication date should be December 4th for the book. And so with that, I think we can start our discussions. So I'd like, so in the joint workshop between VeriDevOps and the book author, and so I'd like to remind the audience what is VeriDevOps project, what it's all about, and give you some motivation in why the cybersecurity and DevOps are kind of connected and need to be addressed like simultaneously. Right. First of all, just a small reminder about important and what is the state of the cybersecurity today, right? So we have the recent data, and this data shows that we have more and more vulnerabilities discovered with a huge spike right around 2017, and if you can see between 2021 and 2022, we actually have 5,000 different vulnerabilities discovered in the world. So cybersecurity is very much important, and also, I mean, it's actually getting more and more important and more people involved on the both sides, from those who actually try to detect and fix vulnerabilities, and also those who want to exploit vulnerabilities. Right. So it should be noted that there are like network vulnerabilities, application vulnerabilities, full stack vulnerabilities. So application vulnerabilities represent around 20% about all vulnerabilities, but inside of this application vulnerabilities, there are higher, let's say, proportion of the critical risks, so the critical things, critical threats, let's say, for the companies that could actually affect the businesses, people lives, users. So, and it's important to address that. Also, on the other side, it should be mentioned that many systems have multiple vulnerabilities. So at least 80% of systems have at least one vulnerability. 70% have more than one vulnerability, and many systems, like about 20%, have more than 10 vulnerabilities present. So it's based on the research of HCloud group, and they also mentioned several other informations about the cybersecurity domain that I will discuss a bit later. Also, in terms of what is the main target of vulnerabilities, applications remain the most common attack vector. So if you look in database, 80% of public exploits. I actually published before vulnerability report is released, which is actually quite a difficult situation. So in terms of how difficult it is, or what's to remediate the difficulties, so HScan in 2022, they actually get various interviews with various representatives from various industries, and they noted that average time to remediate the problem would be 57 days, which is quite a lot, because during this time the system is vulnerable to attacks, and it's very necessary to protect system from being exploited. So if you look to various industries, so public administration, they have about 90 days, 3 months before the problem of vulnerability is closed. Manufacturing, 78 days, also 2 months and a half, almost 3 months. So, and we see in the other industries, it is a bit the same. So quite a long period till the vulnerabilities are present and not addressed properly. So that is to say that there should be some methods, there should be some ways to improve the situation, to reduce this time to repair, time to remediate, so that we have a less risk of economic losses and people's lives affected by the security breaches. Right. So just to understand why this takes so long time to address vulnerabilities. So OVAS published a very nice diagram about how this process on vulnerability remediation goes on. So imagining we are in day 1, day 0, or 0-day vulnerability is discovered. So between the moment the vulnerability is discovered and vulnerability is made public, there is some period of time. Can be short, it can be longer, but at some point vulnerability gets published, right? It's get known to the vendor. The vendor rediscovers this vulnerability. Then vendor should do something and probably notify. Good idea to notify clients that there might be something affecting the clients with regard to this vulnerability. Then at some point the security tools get dated with new signatures added to the tools. Then vendor creates and publishes a patch that would actually solve or close this vulnerability. Then existence of the patch would be known by the clients and other users. So, and at some point, the patch will be installed to all affected systems. And so this time can be quite long. As we saw previously, it could be up to 3 months for the whole process. And that's all this time, the systems are vulnerable to attacks and potential threat for the companies and users. Right. So the thing is, so if we can, to some extent, address and shorten the time at each of these stages, right? So it will be quite nicely accepted by the community. It will be provide more protection to the users and companies. Right. And so this somehow motivates our research on how to make these repair cycles faster, not to inject errors at development time, how to detect attacks and detect all anomalies at the runtime, how automatically address those and locate the faults in the systems, and how to kind of update that in a quick cycle with in the DevOps environment. Right. Okay. So some more, let's say, so some more statements from the industry. Many organizations, more than half, run legacy platforms that are no longer supported. More than the half companies say that they do a lot of manual work when they need to patch the systems, patch vulnerabilities. Many teams say that are disadvantaged and there is too much of manual process to deal with vulnerabilities, and it's difficult to decide and correctly prioritize the level of each software patch, and so difficult to understand. So, what first needs to be done, what first needs to be addressed with regard to cybersecurity. To summarize the challenges, we see that security vulnerabilities touch all the industries, like internet, cars, railways, automotive, like Industry 4.0. And number of the security scenarios explodes. So we have applications, network vulnerabilities, operating systems, all the infrastructure vulnerabilities. And those vulnerabilities are threats to the companies and users. That can actually increase production and maintenance costs, but also harm economic situation for the companies and also harm the users. So how to address that? I mean, there are classical ways to address that. First of all, it's a good idea to build and reinforce security mechanism within the developed systems. So it's commonly known that retrofitting the security into design of the system is very difficult, right? And the security should be addressed from establishing the good and right requirements about what needs to be done to secure the system, also during the development through adding specific security practices in development process, also in deployment and monitoring at operations. So it actually follows quite well what we call currently CI/CD and DevOps cycles. So it is a good idea to integrate all these measures as a part of day-to-day work of developers, and preferably in automated way into CI/CD. So for that, we need to actually spend some time, because it happens that it might be actually quite difficult, not particularly understandable how to do that. And so today we're going to present several interesting practical methods about cybersecurity, how that could be addressed in DevOps. Right. So to recap the overall challenge, typically the vulnerabilities are collected through specific databases like common vulnerabilities enumeration and common weaknesses enumerations, attack vectors, and CAPEC. Also, there exist many security standards like control systems. They could be specific security requirements coming from companies. So and operations verify that. And so the thing is, most of the time it's right. So the idea is, let us do some automation in various stages of the DevOps cycle, starting from planning, creating, verifying, packaging, releasing, configuring, monitoring. And how to address that? First of all, let's try to automate as much as possible security requirements analysis using NLP methods, specific quality checks for security requirements, and to help to get from security requirements into formalized, formally structured or semi-structured formal models that would be then exploited in test generation, vulnerability localization, but also on the other side in passive testing, monitoring, and countermeasures. And on top of that, adding up systems that would detect anomalies and something that we actually haven't foreseen on the requirements level. So that requires development of various things. And in our project, we said that we will explore NLP methods for security requirements analysis, for formalization. And from this formal specification or formalized specification, if you want, we would first protect the systems by playing with anomaly detection and root cause analysis, adding up vulnerability scanners, controlling and configuring rule-based monitoring based on security requirements. On development side, so to address vulnerabilities, we would make design checks, but also some automated tests that are generated from formal specifications that all integrate in some continuous integration and delivery system. Right, and that would create like environment for vulnerability discovery, reporting, recommendations that should be back addressed in the system through automated pipelines. Right. So we created a methodology and made many tools that I will not discuss today, but probably in the next workshop. With a lot of tool chain. In essence, in the project, we have 10 use cases coming from our industrial partners, that is ABB and Fagor. We developed more than 12 various tools that integrates in CI/CD cycle. And we are quite happy that we have many papers, including this particular book, to really talk about these subjects with the broader community. Right. And I think with that, we can switch to the main part of our research workshop.